Thanks for joining us, everyone. This is ProServeIT Academy and our Data and Analytics class. Our topic today is Data Warehousing Architecture Patterns. This class will explain the functions of a data warehouse and look at the evolution to data lakes and data lakehouses. My name is Betty Kwan, and I'm with the marketing team at ProServeIT. Presenting today will be Scott Sugar, Practice Lead Data and Analytics at ProServeIT. And before we launch into the class, I'd just like to mention a few housekeeping items. I would ask that you please keep yourself on mute unless you want to ask a question. This will minimize background noise. You can also enter any questions in the chat. We'll answer your questions during a pause or our Q&A time. We are recording the presentation. You will all receive a copy along with the presentation deck for your reference. We'll be sending out an email with those in a couple of days. And during the class, if you experience any audio or visual issues, we suggest you drop from the session and join again. Okay, with that, I will turn it over to Scott to take it from here.
Awesome. Very nice to meet everyone. As Betty mentioned, we're going to go through data warehouses architecture patterns, or a brief history of data warehousing. So I do remember a couple of the names from the last session. The last session was all around data modeling, and kind of why we do reporting from data warehouses with data models applied to them, as opposed to just reporting out of our source systems. This time it's going to be a little less technical, and we're just kind of go through the history of data warehousing. So now that we understand why we do data warehousing and some of the data, the main data model, the star schema that's used within data warehousing. And if you don't know what I'm talking about there, the prior video, I believe, Betty, it's available. And then this time we're just going to go through the history of data warehousing and some of the newer architecture patterns. So some of the newer styles of data warehousing, and even get into some of the other types of data warehousing. So I am the instructor, practice lead, data and analytics, agenda. So we're going to go through the data warehouse. We're going to go through the data lake. We're going to jump into the data lakehouse. We're going to have a big comparison table that's probably not ideal for a PowerPoint slide because it's a bit wordy, but it's real great for after the fact if people want to look and understand what the comparisons between the data warehouse, the data lake, and the data lakehouse are. Then I'm going to touch on some other approaches. So, not everything is data warehouse, data lake, data lakehouse. There are other modern options for your data infrastructure out there, or your data architecture out there. So we'll touch on a few of the main ones, or the ones with with a lot of buzz around them right now, and then we'll do questions all throughout. If you have any questions, feel free to raise your hand. Feel free to unmute yourself and let me know what the question is, and we can do that along the way, and then we can also do a Q&A at the end. At the very end, we'll do a little bit of the data maturity matrix and customer journey. For people that saw the first session, that piece is going to be pretty much the same. So I'll try and rip through that real quick and let us spend most of our time, up here in the stuff that you're here to learn about. So diving, any questions about the agenda before I dive in? Awesome. So the traditional data warehouse, real briefly, this spans all the way back to the 1960s. The terms dimensions and facts, which we talked about in the last session, that's when they were first developed. Then you have Mr. Bill Inman in the 1970s, starting to define and discuss what data warehousing is and why it's going to be useful. In the 1980s, you have the first software applications that are true data warehouses being developed. And then in the 1990s, you've got, what are considered the grandfathers or the godfathers of data warehousing, Ralph Kimball and Bill Inman. They're publishing their books and their takes on data warehousing. What is the data warehouse? Really, what you're doing in the data warehousing world is taking structured data from a whole bunch of different systems. So it could be, typically it's other relational databases. So you have an ERP with a backend database, you have a timesheet system, you have a CRM, you have a professional services tool. All of those systems have data in databases. Back in the early days of data warehousing, you then extract that data from those systems, you land it into the data warehouse, which mainly allows you to perform data management and governance on the data in your warehouse because it's in a relational database. And then that flows out to BI and SQL analytics. So it allows for business intelligence, so reporting, as well as further analysis on the data in a SQL format. Any questions about data warehousing? Just the overall high level, we're good? Awesome. So the benefits of data warehousing, these are the kind of main benefits. So it allows you to integrate multiple data sources into a single data model, which is what we talked about last session. It allows you to maintain data history, even if the source systems do not. So if your help desk ticketing system doesn't track how things move over time, how a ticket changes over time, it just tells you, hey, here's a point in time, look at the ticket. The data warehouse, one of the ideas here is that you can track some of those things over time, so that way you can see the flow of a ticket and these kinds of things. It's meant to provide that single source of truth for all of your reporting. What we see with a lot of clients is different people bring in different reports to the meeting room. One person's report says this is the number, another person's report says that is the number, and then the discussion devolves into whose numbers are correct rather than what should we do about these numbers. So the idea of a data warehouse is that you have a single source of truth, so that way there's no major discussions about whose data is right. You get to have discussions about, hey, here's what the data says, what do we all do about it? The other thing is restructuring or transforming the data from the source systems so it makes sense to business users. We work with ERP systems, and the fields in those ERP tables are just a series of numbers and letters. And for a normal business user, they're going to have no idea what the LMHB TYX field means. But we can then transform and clean some of this and change those field names as one small piece of the transform puzzle. But as an example, we can change those field names into, hey, this is your, customer first name. And now business users are going to have a better understanding of what the data is. As we talked about in the last session, data warehousing improves query performance because it denormalizes the data. Again, for people that doesn't make sense to, go back and watch that first session. And we talked there about how query performance is improved by not having to do a whole bunch of complex joins because you're denormalizing the data. And data warehousing is really ideal for that BI and SQL analytics, as I mentioned on the prior slide. The drawbacks of data warehousing. It's difficult to deal with semi-structured data, and it's almost impossible to work with unstructured data. So you're not going to land an audio file into your data warehouse. You just can't do that. Or if you do that, you're not really able to analyze it in any meaningful way other than here's the file name and here's a link to it. So again, the data warehouse is not ideal for dealing with semi-structured and unstructured data, which is becoming more prevalent nowadays. As you pull data out of APIs from some software as a service application, they're typically landing it in a JSON format. And now you've got to work with that JSON format, transform it, change it into a CSV or something So that way you can load it into the data warehouse, because SQL just typically doesn't work well with those semi-structured. And again, unstructured data, it's not going to work with very well at all. The other drawback of the data warehouse is that it takes a real long time to create ETL, ELT pipelines. So extract, transform, load, or extract, load, transform, whichever pattern you're looking at there. It can take a long time to create those. Now, I would argue that you get good value by creating those, but again, it does take significant development effort. It takes some specialists to do that often. Now, and again, things are getting easier, and the low code, no code stuff of places of tools like Azure Data Factory or AWS Glue are making this easier and easier, but there's still development time required there. The next one, that single source of truth is actually really hard to achieve. A lot of people would refer to it as, the holy grail of data warehousing. And this is mainly because your business is constantly changing. Your business processes, the systems that you're using, you might add a system, you might replace a system, you might remove a system. And then just your reporting requirements are going to be changing on a regular basis. So it's really hard to get to that single source of truth, and then it's really hard to maintain that over time. And given that when you make changes to your ETL, ELT pipelines, it also takes a while. This just can become tricky to achieve without, giant efforts. The other problem is data warehousing. Oops, sorry, I just wrote over that. Data warehousing is really not ideal for machine learning. The main reason being that in the data warehousing world, typically you're cleaning, filtering, and transforming the data, whereas machine learning often works best with raw data. So there's a great story I heard of a team that spent 6 months doing credit card data for a credit card company to find spending patterns of users. And so they spent 6 months cleaning, filtering that data. They were, finding things like the multiple card swipes that didn't work, removing those because they just wanted to see the card swipes that work so they could track spending patterns and this and that. They finished it all up, released this thing, and some of the departments in the bank loved it, and then the fraud detection department came in and said, yeah, we want that data that you just did. And they sent it to them and they said, yeah, well, we need the raw data. We can't use this because we want to see all those duplicate swipes to find out if there's fraud happening here. So, when you're cleaning, filtering, transforming data, you might be removing some of the patterns that are available dealing with raw data. So, and that's really where machine learning is key, is getting access to that raw data. Any questions about data warehousing, whether it's the timeline, the data warehousing overall, or these benefits or drawbacks before we start moving on to the next architectural pattern? Okay. So jumping to the data lake. Data lake's a lot newer. 2011, data lake term was first coined. By 2016, every major cloud vendor had their own data lake in place. Azure, Amazon, and Google Cloud. And then by 2018, so 2 years later, we already had the idea of the data swamp, which we'll dive into a little bit as we get into this. Now, one of the main things of the data lake is that you can take structured, you can take unstructured, you can take semi-structured, unstructured, any data that you're interested in, whether it's movie files, audio files, pictures, structured data, and you can land it into the data lake. Now, this is a direct outcome of some of the perceived drawbacks of data warehousing. So data warehousing doesn't work well with unstructured and semi-structured data. The data lake does. In the data warehousing world, you don't typically have raw data, which is useful for machine learning. The data lake is built off of raw data typically. So it's kind of coming out of the data warehousing world to say, hey, here's the problems that we saw with data warehousing. Let's try and fix them with the data lake. And we can see, our benefits, real low cost. Right now, a terabyte of data lake storage on Azure is, I believe a terabyte is like 10 or 20 bucks a month in Azure. It's probably even cheaper than that in AWS. So, we're talking about very, very low costs here for saving huge amounts of data. In the data warehousing world, a terabyte is hundreds of dollars a month easily. And you got to get yourself to a scale of data warehouse that can actually handle a terabyte of data, and that's even more expensive. So the data lake, real low cost, you can rapidly ingest data because you're not doing the transform piece of things. You're really just extracting data and dropping it into the data lake. Handles any type of data, structured, semi-structured, unstructured. You've got audio files, you've got video files, you can land those in there, no problem. One of the ideas is that it breaks down data silos. It's questionable whether it really does this or not, but the idea is, hey, I can land everything I have into this data lake and read out of it. And then the data lake is ideal for machine learning, given that you're dealing with, raw data that machine learning is great at finding patterns in. The drawbacks. So data lakes do not have the same management and governance capabilities of a relational database. It doesn't typically track metadata, the data types and fields and things like that a data warehouse does, given that a data warehouse is typically a relational database. Given that it doesn't have that same management and governance capabilities, it can often become very disorganized very quickly, leading to, the dreaded data swamp, where you've got a whole bunch of data just landing in there. No one has any idea what's in there, and it just sits there and doesn't do anything. Or some data is being used from it, but the effort and costs of doing what you've done so far, you're not really achieving as much as you could. It's usually slower to query from than a data warehouse. The gap here is getting smaller with respect to performance, given some of the newer technologies out there. But reading from flat files in a data lake is never going to be as fast as reading relational data out of a data warehouse, especially when you're trying to read subsets of that data to say, hey, I want to select this from here, where that. In the data lake world, you have to query that entire data set, and then you can do the where clause. In a data warehouse, a relational database, it's smart enough to know, okay, this person has asked for this set of data, where that, and it can filter it down before it returns it to you or even processes it. So it's always going to have a performance increase there at the data warehouse level. And then data lakes, they're not ideal for BI and analytics because you're having to do a lot of the cleaning, filtering, augmenting of data after the fact. And if you do that at the reporting level, you're building out these black box reports that are not ideal. And if you do it at the data lake level, you're needing to layer something on top of that in order to do that, which is possible, but again, the data lake isn't ideal for this. Any questions so far about data warehouse, data lake? Okay, cool. So we're going to get into the data lakehouse. So data lakehouse, first coined in 2017. The Delta Lake project started in 2019 by a company called Databricks. In 2020, Apache Iceberg became a top-level Apache project. It had been in development by Netflix and Apple from about 2017, 2018, but became that top-level Apache project in 2020 and has been gaining traction. And these are kind of the basis for lake houses. These two projects here, Delta Lake and Iceberg. And as you can tell, these are real new. We're talking, 3 years that these have really been, heavily used. And I would say probably it's the last, 12 to 24 months that companies have really been adopting these in any meaningful way. If we look here, the idea of the data lakehouse, and as you can probably tell from the name, it's attempting to combine the best of the data warehouse with the best of the data lake. So you can land any data you want into this. You're doing your same extract, transform, load stuff. You're able to stream real-time data through. You're able to do what they would call textual ETL. And then you're landing that into a data lake, and that's that data lake image up here in the top of this silo. But you're able to apply that same level of management and governance that you would apply with the data warehouse. And the way they do that, if you look back at Delta Lake and Iceberg, these sit on top of flat files, like in a data lake, but they allow you to do SQL on top of those. So you can do merge statements, you can do your inserts, updates, whatever you can typically do in a SQL world, you can do on top of flat files now, given what these two projects, Delta Lake and Apache Iceberg, have brought to the table. Because all of this now is, you've got your raw data sitting in the data lake with the curated data sitting on top or under it in here, but really on top of it. It's ideal for BI and analytics, real-time data applications, and as well as data science and machine learning. So the idea here is that you're putting together a single platform that allows you to do all of this. Now, what we've seen, and one reason that I believe this is a good architecture moving forward, we've seen with a lot of our bigger clients, we would build them a data warehouse and a data lake. And in some instances, they would have analysts that said, hey, I want access to the raw data, and we'd have to point them to the data lake. And in some instances, we would have the standard BI reporting being built, and we would have to point them at the data warehouse. And it meant that we were pointing people to different places. And if some of those changes didn't flow through correctly, they were almost sometimes working off of different data sets, which is obviously not ideal. In the data lakehouse world, the idea is that you're landing your data into the raw format, and then you're building on top of that raw format to do your cleaning, filtering, augmenting, and then your data modeling. And in that way, you have one cohesive system, and you can point your analysts or your BI users into that system at different levels, but still keeping that same data set and just allowing them, hey, you can look at the raw data, you can look at the cleaned, filtered data, you can look at the fully modeled data. And you're not having to do a whole bunch of additional work to land different data sets in different, raw data sets here, clean data sets there. It's all cohesive and in one system. The benefits. It marries the flexibility and low cost of the data lake with the management and governance capabilities of the data warehouse, which is kind of what I've just gone into there. So you can land that structured, unstructured, semi-structured data. You're still achieving low costs for storage because everything is backed by the data lake. And then with Delta Lake or Apache Iceberg technologies on top, you're able to layer that management and governance on top of it. And given that you're able to do all that, it's useful across BI analytics and machine learning without needing to duplicate that data, as I just kind of mentioned there. The main drawbacks here, really, it's still an emerging technology. And given that it's still an emerging technology, we might not have the full picture of the pros and cons of this for a few more years. Some people would also say query speeds out of the Delta Lake are a bit slower than a data warehouse, which I would agree with now. But there are, one of the main focuses of development in those Apache Iceberg, Delta Lake areas is query speed. And I think there's a lot happening there that in the next few years, you probably wouldn't notice the difference between having a lake house and having a traditional warehouse. Any questions about data warehouse, data lake house? I know I've gone through a whole ton of information real quick. Any questions? And I'll just ask a question of everyone. Does everyone have a better idea of what these technologies are and how they play together now? Hands up.
Yeah.
Or speak.
This is Jason here. Yeah, absolutely. This is very helpful.
Awesome. Yeah, cool. Getting some thumbs up. Awesome. Cool. Thank you, Betty. Number one supporter. So here's the comparison. As I said, this is not an ideal PowerPoint slide, given it's pretty wordy there. But it's a good comparison. We'll definitely share these slides out with anyone who wants them, and then you can get access to this and see it. But really, this is just providing you a comparison across those technologies, across a number of different areas. And really, it's kind of what I've been speaking to through this whole presentation so far. I'll just leave it there for a sec for people to digest or take screenshots or anything like that. If you see that link at the bottom there, the Databricks evolution to the data lakehouse, it's a real good blog. It's a fairly quick read, and it also does a great job walking through how we came from data warehousing into data lakehousing. Cool. So as I mentioned, there are some other approaches out there other than data warehousing or what's come out of that data lakehousing. One of the big ones that's been around for a while now is data virtualization. So what they typically provide you with is a virtual data layer. That virtual data layer gets connected into all of your different source systems, your ERPs, maybe another data warehouse, a SQL server, a NoSQL bog, whatever you got, even some different web services they can hook into. And then you can write queries at this level, and this system will then push those queries down to these systems and retrieve the data back that you're looking for. the benefits here, and one of the things, if you talk to Denodo, I believe their name is, or a Cloudera, or a Starburst, there's a whole bunch of companies that play in this space. One of the big benefits that they'll tell you here is you don't have to spend that time on ETL anymore. You don't have to do the extract, transform, load. You just connect our system into, you connect that vendor system into all of your source systems and start writing queries, and you're off and running. That's true that you do get that kind of instant access without having to go through the ETL process to, everything you've got, assuming that that vendor has connectors for all the different systems you use, or you can, do some development to finish writing a few connectors that they might not have yet. There's two drawbacks that those vendors might not surface so quickly. And it's real core to what data warehousing does. So one drawback is that you are increasing the load on all of these systems, especially if you're trying to run queries during business hours. So to get around that, some of these systems will have caching engines that allow you to cache the data in the virtual data layer, or just below that virtual data layer. They'll have a caching engine that allows you to save that data. So there are some ways around that first issue. The second issue, if you remember back to that data warehousing slide where I said, even if the source system doesn't maintain history, the one benefit of data warehousing is that you're able to track history. With the data virtualization, I haven't seen any solutions out there that allow you to really track that history, because you're really getting a point in time as to what's sitting in that source system when you execute your query. So that's kind of, virtual data virtualization. I do believe there is a space for data virtualization. I think it's really in the rapid prototyping world. So if you don't really know what you got and you want to connect into a bunch of stuff quick and have some analysts start writing out some queries to start doing some initial work, I think that makes a lot of sense to layer on, data virtualization to allow you to do that. Long term, I still think that there's a place for writing your extract, transform, or extract, load, transform pipelines in order to retrieve data from these systems, land them into a data warehouse that you can then query off of. Any questions about data virtualization? Cool. The other approach that you're going to see that has a lot of buzz right now is data mesh. Data mesh, data fabric. And really what this is it says, the core concept here is keep your data in the source systems, and the owners of each source system are responsible for preparing the data for, reporting or analytics. And that's where you get this federated data. Means that you're allowing the people that own this data domain, whether, maybe that's an ERP database, to be in control of that. And then the person over here that's in control of your CRM database, they're in control of that. So it's decentralized to that. And all of these are connected together such that it's, you're federating between all of them. And then the idea is that there's a query engine, typically sitting just outside of this or in the middle. And then you can write your queries out to those source systems. The problems here that I see are real similar to the data virtualization problems. One, it's tricky to maintain history if your source system doesn't maintain history. You're pushing a lot of the query down to the source systems. So those source systems, can get overloaded if there's lots of querying happen during the day. Some people might go to the level of each domain has to have its own data warehouse where you're doing that ETL. And that's a possibility. But then you're still incurring a lot of the same development costs as if you're just doing a standard enterprise data warehouse instead of, a federated data warehouse or a decentralized data warehouse across each domain. So I think there's some use cases for data mesh, especially in companies that have highly segregated units, and each unit wants to have their own kind of data team in place. I think there's a use case there. I'm sure some of the data mesh vendors would also have some great use cases, but just wanted to highlight that this is another approach. Again, data mesh is very, very new. Probably I started hearing about it a couple years back. So, it's still in its early days. I think we'll start to see in the next few years how this actually plays out. Is it going to provide some useful solutions, or is it gonna, go away and other things, take over? And like anything in IT, the landscape's always changing. Any questions about data virtualization or data mesh? Cool. That really is the bulk of my presentation here. There's a couple more things I'll walk us through, but just wanted to stop to allow any questions about data architectures, whether it's warehouse, lakehouse, virtualization, mesh, or any other architectural pattern you might have heard of, or other questions or thoughts on life in general. Feel free to ask away for the next couple minutes, and then we can jump into some other stuff.
I kind of like the thoughts on life in general comment. That was good. just want to show you I'm paying attention. That's no, but this is actually, this is great. This is the brain's churning as I'm seeing all this stuff, but I'm learning a lot of new things too, though, that I hadn't even heard of, to be honest with you. So yeah.
Awesome. Yeah, that thoughts on life in general, it was from a high school teacher I had. He would, at the end of every class, he would ask us, questions, comments, thoughts on life in general.
That's perfect.
And yeah, I loved it. So I've
Yeah.
kept it going for a long time now.
I'm going to steal that one shamelessly. So yeah.
It's all yours. No
Yeah.
worries. Cool. For people that were here last time, I think you've already seen this. This is this is our maturity matrix for data. Remind me next time, Betty, to have a zoomed in view of the insights and automation area. Forgot to do that. We do have one of those, but I'll read through this real quick. Level one, what we see in level one for data is, companies are doing spreadsheet reporting. They've got real complex Excel formulas. There's a lot of manual cut, copy, paste going on. Difficult to integrate data from multiple sources, and there's often a dependency on key individuals for knowledge. Where we typically try and take clients through a level up project is to get out a baseline report set. So maybe these are, executive reports or an operational reporting package, something like that. We make sure that the infrastructure we build, whether it's typically what we're building nowadays is either traditional data warehouse for companies that aren't as interested in bleeding edge. But more and more we're seeing companies adopt that data lakehouse approach. Either one of those approaches, we're building out that automated data retrieval, data refresh through ETL processes. And then, using either of those approaches, it's real easy to integrate multiple data sources together. Level 3, what we think companies should do as they're continuing their journey. Integration of external data sources. So pulling in, we see oil and gas companies pulling in weather data so they can see what's happening from that perspective. AI, ML, sentiment analysis, price optimizations, market predictions, things like that. Fraud detection, you'll see other things like that too. And then mobile dashboards and scorecards. So not just limiting yourself to having to have users sitting in front of screens, laptop screens or desktop screens in order to see reports, but making those reports mobile friendly is something we see going on. Even beyond that, one arm of our company is doing some very cool stuff with Meta or Facebook, whatever you want to call them nowadays, with their, what are they called? The Quest Pro augmented reality, virtual reality headsets, where they actually have Power BI reports floating in the air now, which is kind of cool. So
like
there's some of
Minority
that
Report.
Yeah, we're
That's
getting
awesome.
there where
That's awesome.
your hands are going up and touching things on your Power BI report screen. I've been told that I am going to get a chance to put on one of those headsets and play around in a couple weeks, so I'm excited for that. But that's where things are headed. Maybe we'll see what other companies think of the Meta's future of work concept. So, but Microsoft and Facebook are kind of collaborating on this space. So all of those Office 365 and 365 applications are now getting layered into the metaverse, which is kind of interesting. As I kind of talked to there, we've got our customer journey, which is really discovery, figure out where you are, where you're going, try and do a quick ROI assessment in there. And that ROI assessment is really around how much time are you currently spending on your manual reporting and how much time can we save you by automating all of that. The step 2 is the level up, which is, building out your foundational data infrastructure, allowing you to integrate data from multiple sources and beginning to create that single source of truth. And then, step 3, I don't know if it's really a step or it's just a non-ending stairway or something like that. But like with most things in IT, you're never done. Your business is going to keep changing, and therefore your data infrastructure and data practices need to continue to evolve. So that's the customer journey there that we work with clients on. And then that first step really is around this data and analytics discovery. This is kind of our one pager for that. If anyone's interested, please let myself or Betty know, or email cloud@proserveit.com. Yeah, kind of what I just walked through there, with the outcomes being an assessment report and an implementation plan. Just so everyone knows, because we get a lot of questions on this, the pilot project, I don't have the slide for it here, but we do surface the estimated cost of the pilot project before we start the discovery. One thing we've heard from customers again and again is we don't want to spend $8,000 or $10,000 and then find out that the pilot is $500,000 and we're never going to be able to afford it. So we have a set price for that pilot that we're able to surface. It's got some bounds on it, some plus minus on it. But we keep it within a fairly tight bound. So that way people have surety that, hey, I can go and do this discovery, spend this money here without the worry that the implementation plan I get is way out of my ballpark, and I'm just spend $8,000 to get a little report. Cool. That's all I've got for today. I'm happy to stay on the line for another however long to answer questions or anything like that.
I'll just mention
Yes.
that our next class is on December 13th. And yes, we will send the entire presentation.
That was really good, Scott. Thank you.
Thank you very much, Jason.
Well, I was going to add in a reminder about the next class into the chat, but I'm having trouble with my Word file for some reason. It is December 13th at 1:30. Hey, great session, Scott.
Thank you, Betty.
Looks great. I will wrap it up with the follow-up email in the next day or so, and you'll all get a copy of the recording and the presentation.
Perfect. Thank you very much.
Thanks,
You
everyone.
all have a great day, everybody. Thank you.
Thanks, everyone. Have a great day.